Today I will talk about the 4D, the fourth dimension. And as we know, so far there are many dimensions in the world, in the construction. I think we have reached the 10th dimension, but for today we'll focus only in the fourth dimension. And we will try to understand what is the 4D, and we will explore some benefits. So before we start, I'd like to share a little bit about myself. My name is Nick, and I'm a lead consultant, work for Laminar. I'm coming from an architectural background. I studied architecture, but after working for some architectural practices, I moved to construction. And I have worked for many contractors and have worked for several construction projects in both tender and construction stage. I have a passion for digital transformation, and I'm always seeking automate processes and mitigate risks through the digital transformation. Now, we'll start with exploring and understanding what is 4D. 4D is more commonly known as the combination of a 3D model with the element of time. In our case, is the project schedule. And the 4D then allows the project team to easily visualize the project schedule in a three-dimensional space rather than a 2D Gantt chart. The 4D model offers many benefits that enhance the planning, execution, and management. And some examples are enhanced visualization and communication, improved project planning and scheduling, cost management, resource management, and improves coordination and communication. The 4D model can be used to visualize the schedule clashes. When we are talking about clashes in the 4D, we are not talking about the physical or 3D clashes. We are talking about task or activity clashes when a task or activity clash with another. And to visualize the schedule, because 4D model provides a better understanding of how the project will unfold over time. It can be used to visualize plan versus actual schedule. It's with this dynamic approach, we can have two different schedules in a single report and visualize the difference between them. And this can help to maintain project control over the project. We can capture viewpoints of areas where the schedule can be optimized, where are some opportunities and opportunities to improve the schedule, so we can deliver faster. And if we can deliver faster a project, that means we save money, because in construction, time is money. We can optimize the schedule during tender stage. That gives us great confidence during bids, and also we can try and be quicker than others competitors. We can also visualize areas where the schedule is ahead or behind of baseline schedule. If when we compare like two different programs, see the areas where we are behind in the actual versus the ahead. And we can also communicate complicated sequence with other stakeholders. That's very important, because sometimes even going through the 3D model or drawings, or even go through the 2D Gantt chart, we cannot understand a sequence. So 4D helps us to understand everything, and because of the visual clarity, it helps everyone, and everyone is on the same page. Now, reviewing a schedule within a 4D environment is much easier than using a 2D Gantt chart, as 4D models highlight discrepancies and show the sequence of tasks and time in time and space. But this makes it easier to spot and identify issues in the program where we wouldn't be able to identify in a 2D Gantt chart. But 2D Gantt charts are still essential for detailed planning, as they provide a clear breakdown of tasks, durations, and dependencies. Together, the 4D and the 2D Gantt charts complement each other, offering both visual clarity and detailed data for effective planning and scheduling. Now, what information do we need to create a 4D model? In order to create a 4D model, two main things are required: the time we need, which is our project schedule or the program, and a 3D sliced model. And for now, what we'll do, we'll focus more into the 3D slice model and explore this further. What type of models do we have most of the time? We have the architectural, we have the structural, we have the MEP, and we have the civils model. But in order to develop the 4D model, we need to create the construction model. That's our slice model. We never received that kind of model, so we need to do some post-processing after we receive all the models together in order to create, to reflect all the activities we have in our schedule on the model as well. So after we slice and we create our construction model, we import our model and the schedule in a software. The software we're using is Synchro, and we need to link everything, all the 3D objects, on the corresponding tasks. And this can be done either manually or with automated processes. But in order to do it, to create like a process and automate processes, you need to follow some steps. Well, what we do is we try to link everything with a 4D code. And we need to code both the model and the program as well. And in our case, this it makes easier for us to manage the models, manage any updates. We can automate steps and also mitigate potential risks for mistakes. Because if you do it like manually, there is no way you will do some mistakes. And we are using the 3D codes to match everything together. Now, how do we add these 4D codes? It's either on P6, which is a planning software, or Asta, again, a planning software. We're using the activity codes or user fields or columns, anything, however they called in any software. For example, in Revit, it might be parameters. But what are these? They're data, actually. All the data we feed on the model. So we create a model rich with planning data or information. Then after we link everything and we have everything set up, what we can do there, we can start linking all the data we have in the 3D to the program. What information we get from a 3D physical model? We get volume, area, we can get weight, linear meters, everything, all this information. And we'll know if we work with BIM models, they're rich in data. So all the data we have in the model, they can be transferred to their corresponding task they have been assigned. For example, here we have assigned the total volume for the specific task, like for the concrete pour. Then, and vice versa, we can also link all the information, all the program data from the schedule into the model. What information we can get from the model, from the programs, like task ID, start date, the duration, if it's under the critical path, if it's if we compare to programs, if this element is ahead or delayed of the previous program. And we can also add the week number, but for the week number, there are a few more steps we have to follow. And after that, what else we can do? We can start, we can also create smart reports in Power BI. So we can import all the data in Power BI and start visualizing them. As you can see, at the moment, what 4D is not only just an animation we have 4D models, we have 4D analysis. The animation is just a part of the 4D, it's the 4D animation. And now we can continue with exploring some animations and 4D animations and see how they can we can benefit from them. That's an example of a typical 4D animation, where you can see that we can clearly visualize the construction sequence, and it's much easier to visualize the program um, and understand the program, even for someone who doesn't have like a construction background. It's much easier to understand a program, and also they can comment on this. They can during reviews on site. We can pause at any moment and see like where are the areas with opportunities, improvements we can do, or if there are any clashes. We can make adjustments before the works begin. We can monitor our progress, and we can spot and address any conflicts early. For example, here, while this progressing, we can see that if there is space there, why we don't use a space for another activity. And also it facilitates communication between stakeholders, because everyone is on the same page. I've been on construction sites, and I've seen like a wall like this length, and we had the program there. And everyone, when they had to review the program, they had to go through the wall. So it's much easier to have it here. Now, another good example is in planning, any decision have an impact. Is it a bad decision? Is it a good decision? Both have an impact. Now, the bad decision will lead us to delay. What is delay? Cost, additional workforce. So, but you cannot see the impact of your decision early. They have to be made. But with the 4D, you can see the impact of your decision before they are made. In this example, we took a decision to change the workforce for the installation of the walls, and we can see the workforce histogram down there, how this will change. And everyone will say, okay, fair enough, we can do it on P6 or any other software, but why do we need 4D in order to validate it? That's because 4D gives us also the spatial awareness. Do we know if we increase the workforce, if we go for 20 to 24, if 24 people will fit in a space? Or if we decide to increase the workforce in this area, are there any other activities or any other contractors who will be working on this area? So here with the 4D, you have the spatial awareness and you can validate it. And you can also track how change will affect the cost, the workforce, and everything. Now, a great example is you have to plan ahead when you are on a construction, but can you see what you are planning? When you do a 4-week look ahead report, if you do it with the 4D, you get a dynamic report that's constantly getting updated if you do any updates on the program. But if you do it manually, you have to create PDFs with markups to explain, and these might not be accurate. But here, in a single report, we have integrated all stakeholders' information, and we can also avoid potential clashes during the construction phase. If, for example, during the cladding, if we have exclusion zones, how can we check it if we don't have, we are not in a 3-dimensional space? In another example, where we have a clash-free schedule, everything we have run, everything is perfect, and there are no clashes, no issues on the program. Everything works, looks fine, but small mistake not a mistake, but if you miss something, a small detail might affect your program, might affect your cost as well. Because we thought that if we install everything, is fine. We have space, so we can have the equipment installed through the corridor, but the corridor was very narrow and we couldn't turn the equipment. In our case, if we didn't have the 4D to review that, that means that we will have built the wall and then we had to take it down. That means that there will be additional cost, delays, and extra workforce. And if we have the tool to avoid it, why shouldn't we use it? And that's fun for me. Thank you so much.